Hello and welcome back for another VMK in the game development series. In this VMK we're going to be adding another GUI control, and this one is going to be used to track or maintain text that is inside of our GUIs. We already have a function or a class that allows us to render text to the screen, but what we're going to do is wrap this up into a separate GUI class so that we can then use this new GUI control in a similar fashion that we use all of our GUI elements. This will make things a lot easier a little bit later on when we lay out all of our text and images and buttons for the GUI that the user will be interacting with. So let's get started. Let's go into our project, and what we're going to do is create a new CPP, a new .h file. So under the object lib, just select Add New Item. We're going to be adding in GUIText, and do this again for the header file. Okay, at the top we have our core, our font.h, and our GUI control.h. Because we are going to be tying into our font class, we do need to include font.h. Down here we're defining our GUIText class, which is going to inherit from GUI control, and our constructor is going to have our ID number, the font ID number. This is the same font ID number that we generate whenever we create the font. So before you create a GUI text control, you have to make sure you've already defined all of your fonts. We have position, we have color, we have a scale factor. Next, we have a function that we can use to set the text that this GUI control is going to be showing us. So we have set text. And then we have our three functions that are required because we're including GUI control. So we have check hotspot, stop pressing, and render. Down here we have some member variables. The fonts are going to be handled in an interesting fashion in this class. So what we're going to do is we're going to use a static member variable, which is going to be a pointer to an std vector, which is a container of font pointers. This guy here is actually going to be pointing to let me go into our scene lib. Under our scene, you'll notice that in here we have, where is he? Right here. We have, for every single font that we create, we're going to be placing him inside of this container, std vector font pointers. But this class, our GUIText class, is going to need to know about that specific member variable. So what we're going to do is we're going to create a static member here that's going to be part of GUIText, but it's going to be pointing to this member variable over here. And by using this guy, we can then figure out whether the values that are getting passed in here are valid and other interesting things like that. We also have the font ID number stored here. We have the text that this GUI control is going to be displaying. It's going to be saved inside of this member variable. And then we have our color and our scale factor. So save that, and let's go into our CPP. Okay, starting off with the constructor, we're passing in the ID, the font ID, the position, the color, the scale factor, and then don't forget to also add in the GUI controls constructor here, and we're passing in GUI_text because this GUI control is going to be a GUIText control. We're then saving the ID number, the font ID, and the position into our member variables here. We're taking the color, we're saving that as well. And the scale factor, we check to make sure it's valid, so we cannot have a scale of less than or equal to 0. So if the user passes that in, then we automatically default to 1. And then finally we take that scale factor and we save it into our member variable. Our destructor doesn't do anything, so it's blank. And then down here we have our set text. So this function will specify what the text control should display. This function also calculates the size of the text so that the hotspot detection will work properly. With all the GUIs, we have a hotspot that's associated with them. And this hotspot is used whenever we use our mouse to highlight over top of different things. Well, we need to know how large our text is, so we're going to create a function to calculate that, and after it's calculated, we'll then go and update our hotspot size after we call the setText function. So first thing we do is we take this variable here that gets passed in, and we parse it out, and we save everything inside of our own member variable m_sz text output. We're saving just 127 characters that is passing in here because our container is only 128 characters long, and then we're null terminating the last character with a 0 here, so that if the user does specify here something that's longer than 128, it just gets chopped off at 127 characters. I don't remember if we've used this function before. Let's just do a quick search here for this guy. No, we didn't. So that tells me that we probably should change some code elsewhere whenever we did use this function here. Let's take a look. Where was it? Oh, inside of ErrorHandler. Set error. No. Here it is. Okay, here we're passing in a variable which is going to contain some string text, and we're saving it inside of this member variable. But this guy here may overflow if this value that gets passed in here is greater than 124 characters long. So we should have actually changed this as well. But before we do that, let's just do a quick search to see if there's any other places that vsprintf was used. Looks like there is one other location here inside of our scene. So we'll also go in and correct this guy as well. Very easy to fix. As you've seen in here, we can replace our function with _vsnprintf, and this will give us the protection to make sure that we aren't overflowing into our member variable. First parameter is the same as it was before. Second parameter, though, specifies what's the maximum number of characters we're going to be able to save inside of this first parameter. So we're going to, because we know that this guy can only hold 1024, we're going to say continue saving until we reach 1023 characters. The other two parameters are the same. After we get all of that, we just need to null terminate him, so that if we did need to crop him, we will be null terminated properly. Like so. So that'll fix any memory leaks that we may have by passing in a really long string into our set error function. Let's do the same thing here for this guy, snprintf, and this guy here is 128 long, so we'll change this to be 127, and then we also need to null terminate him. Okay, so this will protect us from wherever we are here, print text. If we generate some sort of long string here that we want to be displaying to the screen and it gets passed in here, well, what's going to happen now is it actually crops out only the first 127 characters. After that, there's nothing else going to be saved inside of this member variable, so we won't have a memory leak. All right, going back to our GUI control here. All right, so we've saved the text inside of our member variable. Then what we do is we check to see if the ID number for the font that we're passing into the constructor is valid. If it's equal to 0, or if it's greater than the total size of our container that has all of our fonts, we know that this current font ID number is invalid because it doesn't point to something that is associated with a font. So we're just going to return we're not actually going to do anything. Otherwise, what we're going to do is we're going to create a iterator to one of these containers which holds this font pointer. And the location of this iterator is going to be located at the beginning of this std vector, but we're going to offset it by however many ID numbers that are specified in here. So this really is the same thing as doing something like this. I just wanted to show you how to handle this this particularly way because I've been using this kind of notation up till now. But I want you to become familiar with using both. So you can use the iterator to get the location of this font pointer, or you can get this font pointer directly by doing the following. Both of these are equivalent. Anyway, once we have this iterator, we can then call a function called getTextSize. And this guy here is going to be a function we're going to implement inside of our font class. Let me just double check, make sure we haven't done this already. No, we haven't. So you notice there is no function here called getTextSize, but we're going to implement it in this video, which will be responsible for returning the total size of this font, or in other words, of this text that we want to display. Once we have that size, we can save it inside of our member variable, but we can also save it inside of our hotspot size, since that's what we're going to be using whenever we need to figure out whether our cursor is over top of this specific control. Next thing we have is check hotspot, and here we're using that hotspot size, where we're passing in the mouse and passing in the pressed state, and depending on whether we're over top of the hotspot, we're going to set the appropriate member variables here, and then if we're pressed as well, we're going to set this pressed member variable, and then finally we return our own ID number. We have nothing here under stop pressing, and under render, we're doing a couple checks here. We're making sure that the ID number for the font is valid again, because if it's invalid, we won't be able to render it because we don't have a font associated with this text. If the font ID number is valid, we're going to get the iterator again, same method that I used earlier, and then we're going to call printText OpenGL. This is that function right here, which is part of our font pointer. And we're passing in where we want to print our text, so we know exactly where we want to print it in the X and the Y coordinate, and the color we already have from the constructor as well as the scale value, and then the text that we want to display is saved inside of this member variable here. So we're just passing everything into our font class, and our font class is actually responsible for rendering. Our GUIText class doesn't render directly, it's passing the rendering work off to the font class, which does the rendering for us. So that's the way we render everything, and that's basically how the GUIText class works. We just need to go in and implement our one function here to get the size of our text, and I think that will be it for this video. So let's go into our font class and create a new function here. I'll just put it right below output tree. It's going to return a vector or a vertex 2. It's going to be called getTextSize, and we're passing in a string here into our function. Then inside of our font CPP, let's put it right at the very bottom. Okay, so here we go. We have a function to return the width and the height of our text string that is passed into the function. We're going to create a vertex 2 here, and this is going to be containing the X and the Y size, which we're going to be returning at the very end. The Y is relatively easy to do because we know that independent of whether we're using monospaced font or proportional font, the height of the font is going to be specified by the font size. So we can take the font size, convert it to a floating point number, and then save it into the Y coordinate value of our vertex 2 variable. The X size is dependent on how long the string is. So depending on whether it's monospaced or proportional, we have to calculate it differently. If it's monospaced, we know that the spacing between each character is going to be fixed because it's monospaced. So what we can do is we can take the number of characters that we have inside of the string and just multiply it by the font size. And this will give us the total width of our string that is passed in here. So we can save that into the X coordinate. If it's proportional, we have to do a little bit more work because each character is going to be a different size. So we need to go back into our array that contains all the sizes for all of our characters and extract how many pixels each character of this string is using, and then total all of that up and then return it. So the way we do that is we start off by calculating a gap because we want to also figure out, okay, we want to know how wide each character is, but then we want to add a little bit of extra buffer room so that all of our characters are not crunched together. We will specify a spacing between each character, and you'll remember that from back here. We used this UI gap value, which was calculated up here. and the gap was always 0.05 times the font size. So we reuse that value here, 0.05 times the font size, that's our gap. And what we're going to do is go through our for loop. For every single character that is inside of the string here, we're going to take the ASCII code of that specific character, subtract 32 from it, and that's going to be a zero-based number now that we can use to reference our member variable here, which contains all of the spacing. You'll remember back in the video when we talked about the fonts, we created this variable here that contained the x and the y coordinates, or actually it contained the width and the height values for all of the characters that we're going to be using for proportional fonting. So we knew exactly how much we have to offset the characters when we're rendering them. So we can take just the x components, which are this value here multiplied by 2, and get his actual number out of this member variable. Once we have that number, we're going to add the gap to it, because the gap is going to be the width that we have to add to this specific character. Convert that all into a floating point number, and then add it to m_fx. You'll remember that when we initialize vertex 2, it initializes both the x and the y values to 0. So when we first go into here, we're going to have 0 plus whatever this is, and then the next time to the for loop, we're going to take whatever's already in here and continue adding the next character, and so on. So in the end, after it goes through this for loop, we'll have the total length in pixels of this specific string that was passed into here. And we're just going to return v2 size, which has the x and the y values stored inside of it. So there we go. Let's go and compile font.cpp. Oh, I made a mistake here somewhere. Let's take a look. Oh, vertex 2 is probably not defined here. No, it's not. So we now need to include, like so. Okay, so now that's fine, and we can go into our GUIText.cpp and compile him as well. Oh, something missing here. Cannot include font.h. Oh, we are currently inside of which project? We're inside object lib. However, font.h is inside of our scene lib. So most likely what's happening is this project doesn't know about the specific directories that the scene lib is using. So we can go into here under C++, General, and notice that we don't have a scene lib folder. So we need to go into here and just add it in. Let's just add it to the end. So now this project will know, the object lib project will know about the scene lib. So let's go and try to recompile this now. Oh, still some problems here. Print text OpenGL. Oh, I think this is a problem with case sensitivity. Yeah, print text OpenGL is a capital. Okay, there we go. So those are the changes we needed to make to implement our GUIText class. So come back for the next VMK where we're going to go into our scene class, and I'll show you how to use our GUIText to render some text onto the screen.